The digital horizon of 2026 marks the final threshold where static large language models yield to truly autonomous agentic sovereignty globally. We stand at the precipice of a monumental shift where screen-based agents transition into the physical world through advanced robotics and sensors. Biological sciences and machine intelligence now converge at an unprecedented rate, creating a new paradigm for neural interfaces and deep human-computer integration. The trajectory toward artificial general intelligence is no longer a distant dream but a measurable path documented by leading global research institutes and labs. Exponential technologies are currently reshaping the fabric of industrial manufacturing as sovereign artificial intelligence becomes the primary driver of national economic competitive advantage. Enterprises failing to adapt to this agentic era face immediate obsolescence as the speed of innovation outpaces traditional human-led strategic planning cycles. The high-stakes gap between early adopters and laggards is widening, specifically in the realms of automated reasoning and complex multimodal architectures. Today we deconstruct the blueprint for 2027, focusing on the emergence of physical artificial intelligence and the dawn of self-evolving code. This masterclass provides the technical framework required to master the transition from basic automation to advanced autonomous systems within your current business operations. You will gain precise insights into bio-digital convergence and the architectural shifts necessary to support next-generation neural interfaces and biological computing. As a senior architect, I will guide you through the specific benchmarks for 2027, ensuring your strategic roadmap aligns with global standards. By the end of this session, you will understand how to leverage agentic sovereignty at AI Knowledge's power to dominate the emerging digital transformation landscape. The current landscape is defined by the rise of sovereign neural technologies where nations prioritize local model development to ensure absolute data security. Industry pain points in 2026 revolve around the integration of fragmented artificial intelligence tools into a cohesive and resilient enterprise architecture. Organizations struggle with the ethical implications of deep learning while trying to maintain the pace of innovation required by the global digital economy. Research from the Vector Institute highlights the critical need for ethical integration as artificial intelligence reshapes human potential and traditional labor market structures. OpenAI and Mistral lead the charge in frontier model capabilities, providing the raw power needed for the next evolution of reasoning agent systems. The European AI Act and the NIST Risk Management Framework provide the necessary guardrails for developing trustworthy systems in an increasingly complex world. Digital resilience is no longer optional but a foundational requirement for any entity operating within the hyper-connected global digital transformation ecosystem today. We must bridge the gap between theoretical research and practical implementation to harness the true power of generative artificial intelligence for sustainable growth. Understanding the intersection of robotics and the information revolution is key to predicting the upcoming shift toward physical artificial intelligence in 2027. Let us analyze the 4 actionable pillars that will define the strategic direction for technology leaders over the next 18 months of development. Pillar 1 focuses on the transition from screen agents to physical artificial intelligence, where robotics and computer vision enable real-world interaction capability. Applied research from Fraunhofer IAIS demonstrates how industrial artificial intelligence is currently revolutionizing European manufacturing through the use of advanced autonomous robotic systems. Technical standards for AI on AI hardware and networking are evolving rapidly at IEEE Explore to support the massive data requirements of robotics. The convergence of biological sciences and machine intelligence at Nature Machine Intelligence points toward a future where physical systems mimic complex organic processes. Preparing for this shift requires a robust infrastructure capable of handling real-time sensory data and low-latency processing at the extreme edge. Pillar 2 examines the strategic digital transformation return on investment as businesses move toward AI-native operations and fully autonomous decentralized organizational structures. Strategic insights from MIT Sloan Management Review emphasize the necessity of redefining business models to accommodate the scale of generative artificial intelligence implementation. Leading developments in multimodal frameworks at Baidu Research are enabling more intuitive human-machine collaboration across various sectors of the global economy. Successful digital transformation in 2026 depends on the ability to cultivate a data-driven innovation culture and strong digital resilience. Measuring impact involves tracking the efficiency of autonomous agents in reducing operational costs while simultaneously increasing the speed of market delivery for products. Pillar 3 addresses cybersecurity ethics and the urgent transition toward post-quantum defense mechanisms to protect critical digital assets from emerging future threats. The threat landscape of 2026 includes advanced AI phishing and sophisticated attacks on high-tech manufacturing systems, according to latest NIST reports. Zero-Trust architectures at Samsung SDS provide a blueprint for securing sensitive data within high-stakes environments that rely heavily on artificial intelligence. Ethical IT protocols defined by the NIST AI Risk Management Framework are essential for maintaining public trust and ensuring the safety of systems. Securing the path toward 2027 involves integrating privacy-preserving technologies and robust encryption methods to safeguard the integrity of sovereign data. Pillar 4 outlines the implementation framework and governance models required to scale agentic systems while maintaining strict compliance with global regulatory standards. Policy-level data from the OECD AI Policy Observatory provides critical insights into global governance trends and the impact on international labor markets. The European AI Alliance offers official updates on trustworthy standards, ensuring that automated systems remain transparent and accountable to their human creators. Governance for the Global South focuses on practical artificial intelligence for good, ensuring that technological advancements benefit all of humanity regardless of location. Implementing these frameworks requires a collaborative approach involving engineers, policymakers, and business leaders to ensure a balanced and sustainable technological future. Let us examine a real-world architectural prompt designed to initialize a self-evolving code environment within a secure sandboxed cloud infrastructure. This specific framework leverages open-source benchmarks from Hugging Face papers to optimize the technical performance of reasoning agents in complex coding tasks. By referencing the latest GitHub repositories, we can observe how automated agents are now capable of debugging and refining their own source code. The architecture involves a feedback loop where the model evaluates its output against established technical standards to ensure continuous improvement and software reliability. This practical demonstration highlights the transition towards self-evolving code where software systems adapt and grow without direct human intervention in the cycle. Architects can utilize these tools to accelerate development timelines and reduce the technical debt associated with maintaining large-scale enterprise software systems today. Observe how the agentic sovereignty is maintained through rigorous testing and validation protocols that align with international cybersecurity and digital trust standards. This approach minimizes the risk of hallucinations and ensures that the self-evolving code remains within the predefined safety boundaries of the project. The integration of these tools into your existing workflow will significantly enhance your capability to respond to rapid changes in the market. Explore the provided architectural diagrams to visualize the flow of data and the interaction between the different layers of the autonomous system. Connecting these dots reveals a future where the boundary between the digital and physical worlds becomes increasingly blurred through advanced artificial intelligence. The synthesis of agentic sovereignty, physical robotics, and self-evolving code creates a powerful engine for innovation and global economic transformation in 2027. The final realization is that the greatest asset of any organization is now the ability to effectively channel and govern autonomous intelligence systems. Understanding these core pillars allows us to predict the next wave of disruption and position ourselves at the forefront of the technological revolution. The roadmap for 2027 requires a commitment to continuous learning and a willingness to embrace the radical shifts in technical paradigms. Visit AI Knowledge's Power to access the full portfolio of research and the latest updates on the trajectory toward artificial general intelligence and beyond. Join the community of global researchers and architects who are shaping the future of digital transformation and cybersecurity in this exciting new era. Turn knowledge into your greatest asset. Channel powered by generative AI architecture.